Hi, hope everyone's doing well and enjoying their time so far at the EDA Summit and learning a lot about event-driven architectures too. Now, a key part of an event-driven architecture is the event broker. Think of it as the nervous system of your event-driven architecture that is responsible for sending your events from your event producers to an event consumer. Now, there are a lot of key metrics that you need to pay attention to on your event broker to ensure that your event-driven architecture doesn't become an event-driven mess. Now, in this short talk, I'll be going over a few of those key metrics, as well as how an event broker should ideally expose them. By way of introduction, my name is Thomas Kunnumpurath. I run the systems engineering team for the Americas for Solace, the makers of the world's greatest eventing platform. Now, with that being said, let's dig right into it. Okay, so here's the agenda for today's talk. I'm going to start out with the event broker's role in an event-driven architecture. Then I'll go into a few of the metrics that you need to pay attention to from an event broker to ensure that your event-driven architecture is stable and running smoothly. Then I'll go into a little bit about how an event broker should ideally expose these metrics. And I'll close it out with a demo of an application that hooks into an event broker and allows you as a user to visualize some of these metrics. So with an event-driven architecture, you have an event producer. This could be a microservice that publishes a credit card swipe event, and you have an event consumer that needs to receive the credit card swipe event, for example, to do a credit card authorization. Now, to get the event from the event producer to the event consumer, you need to introduce an event broker. The event broker will receive your event, in this case, a credit card swipe event, and will distribute it to all interested microservices. In this case, there is one microservice, the credit card auth microservice. So now that we understand the role of an event broker in an EDA, let's look into some of the metrics on the event broker that you need to pay attention to ensure the health of your event-driven architecture. So you may start out with a single publisher and single consumer microservice, but as you scale up your event-driven architecture, you will have tens, hundreds, and potentially millions of connected things into your event broker. So the number of connected clients is something you need to pay attention to because there is always going to be a finite number of connected clients a single event broker can support. The next thing you want to pay attention to is the ingress message rate. That is the total volume of messages going into the broker. This is important because at the end of the day, the broker is running on some compute that has a limited amount of network bandwidth. So if you're pushing more data into the event broker than the compute can support, bad things will start to happen. It's also important that you get this at a per client level and also at a total level. Equally important that you'd want this to be expressed in both messages per second and bytes per second. Now in this example, you can see that the second publisher is only publishing one message a second. However, each message is 10 megabytes. So that might be a significant amount of network bandwidth that specific publisher is using, and something you would potentially want to catch. Now, similarly, you would also want to pay attention to the egress message rate. That is the total amount of data leaving the broker. Same arguments apply. At the end of the day, your network I/O will always be limited, and you want to ensure that no single consumer is using up most of the bandwidth. You also want to see the egress message rate on a per connected client basis, and also the total amount of data leaving the broker. Another important metric that you want to look at is the latency, which is really the time it takes for a message to be sent to the broker from the microservice, or the time it takes for a receiving application to receive the message. This is important because the further away your microservice is from the broker, the longer it will take for it to receive the event. For example, if you have a broker deployed in AWS and US East 1, and a microservice connects into it from India, it will take longer for the messages to be routed to the end user. So getting latency profile of all your connected clients is important. In this illustration, you can see the last subscriber only has a message latency of 8,000 milliseconds or 8 seconds. So that means that a message once published into the broker will take at least 8 seconds for it to be received by the consumer. So now that we understand some of the key metrics and statistics you should be paying attention to for an event broker, let's talk about how an event broker should ideally expose these statistics. So the main role of the event broker is obviously to distribute events through your event-driven architecture. And getting these statistics or really performing any sort of administrative action shouldn't interfere with the messaging flow. Ideally, you would want the control flow, that is performing the administrative action or retrieving statistics, to be exposed from a different port than your messaging flow. Now, it would be even more beneficial if the control flow went through an entirely different physical network interface card. You also want a well-defined schema as well as documentation that describes the actions available to you through the control port really well. And finally, you want to be able to have some level of administrative control through the control port so you could do administrative actions on your event broker. Now let's jump into the fun part of the presentation, the demo. So I developed a single page application that is able to connect to an event broker, in this case the PubSub+ event broker, and grab some of the statistics that is described and represent them on a chart. Now the application can be brought up locally through Node.js, launched via a public GitHub Pages site, or even brought up locally using an Electron distributable. The application is able to connect to multiple event brokers, and in this case, they were linked together as an event mesh, so I could visualize statistics across multiple event brokers on a single screen. Now, one of the reasons that I chose the PubSub+ event broker is that there is an expressive and well-documented and defined administrative API. There's a public Swagger document that you can generate code off of as well. And so with that being said, let's jump right into the demo. Okay, so the first thing we want to do is open up a Brave browser, go to github.com/Solace community. The Solace community GitHub repo is a set of code contributions from the Solace community. And we're going to scroll all the way down to Sol Charts. Now, once we're into Sol Charts, you have access to the code, and you have a description of the app, a nice animated GIF of the app in action, and you have build instructions, as well as instructions on how to build a Electron distribution. So let's jump right into the Electron distribution to see how you could access it. Just click on versions, and once you're in the versions section, you have a bunch of distributions. You have a Windows distribution and a Mac distribution. For the purposes of demo, we're going to launch the app from GitHub Pages. So the way you do that is you just click this link right here, and that will launch the app. So once you get access to the app, you fill in the connectivity to your broker. So in this case, I have a broker running locally. I'm gonna put in the default credentials and click connect. Now you also see you have the ability to save and load configurations. So I have a configuration file already saved, and I'm gonna load that up right now. And you can see that there are two brokers, my local broker and a SCDS broker. So I'm going to connect to all of those, and once I do that, I click on the Charts tab. So in the Charts tab, I get access to the chart. I put in the label for the chart. In this case, I'll call it the SCDS broker chart. And then I select which broker I want to chart. And in this case, I'm going to chart the SCDS broker, and I want to chart the ingress rate in bytes per second and the egress rate as well. And let's put that in bytes per second too. So that is the total amount of traffic that is going into the event broker and leaving the event broker. The second thing I want to do is add another chart for my local brokers. So I click that button up there and I get another chart section. So I'm going to label this chart local broker. And in this case, I want to chart a specific client attribute. So I will go ahead and click this down arrow to give me access to the client attribute charting section. And I will select which client I want to chart. So I'm going to click this guy over here, and I want to chart the amount of data that this client is pushing into the broker. So that is your ingress rate, and I'm going to do it in messages per second. Okay. So before I click start charting to kick off charting, I want you guys to pay attention to this otter over here. His name is Solace. Once I click start charting, he will start waving at us. Okay, so that's a nice little Easter egg. And from there, the charting begins to happen. And you can see in my SCDS broker chart, I'm pushing about 8 to 9 million bytes into the broker and consuming the same amount. So I have an application that is listening on the side. And let's see what happens when I do that. Okay, you can see that the broker stats are going up. And so the point here is that as you have activity on the broker, that will be reflected in real time on this chart because it's accessing the statistics on the event broker. Okay, now let's look at our local broker. You can see that there's nothing happening on this broker, so you have a client connected, but it's not pushing in any data. And I have an app on the side that is going to start pushing in events into the event broker. Let's see what happens. Okay, you can see that the messages per second start to go up. And Solace is still waving at us, which indicates that charting is healthy. And that's pretty much all there is to the demo. So I'm going to click stop charting. Solace will sadly stop waving at us, and that's it. So you should now have a general idea of some of the key metrics you need to be paying attention to from an event broker once it's deployed. You should also have a general understanding of how an event broker should ideally expose these metrics, and the importance of having access to these metrics publicly documented and well-defined. Once again, my name is Thomas Kunnumpurath. It was fun walking through this demo and through this talk, and please do enjoy the rest of the EDA Summit.